नमस्कार दोस्तों, welcome back to VNP Networking Tutorials. In today's lab, we are going to verify the BGP Split Horizon Rule using GNS3 lab. As you can see in this topology, we have three routers, router R1, router R2 and router R3, and all of them belong to the same autonomous system, which is AS65000, which means we are working with iBGP neighbors. Each router has a loopback interface configured. R1 is having 1.1.1.1/32, R2 is having 2.2.2.2/32, and R3 is having 3.3.3.3/32. Also, R1 is connected to R2 using the network 192.168.12.0/30, and R2 is connected to R3 using 192.168.23.0/30. Now, the main objective of this lab is to understand the BGP Split Horizon Rule. This rule says a route learned from one iBGP neighbor is not advertised to another iBGP neighbor. So, in this scenario, if R2 learns the loopback route from R1 through iBGP, R2 will not advertise that route to R3 automatically. As a result, R3 will not learn R1's loopback network even though R2 already knows about it. This behavior prevents routing loops inside the same autonomous system, but also creates scalability challenge in the iBGP networks. So, in this lab, we will configure iBGP neighbors, verify the route tables, and confirm that the route does not propagate because of the split horizon rule. So let's get started. So let's power on all the routers. And take the console access of each router. You can right click the router and you can go to the console. This will provide you the console access. So we have R1 console, we have R2 console, and we have R3 console. So we have the R1 router console access. Let's begin with the interface IP configuration. So you can enter the global configuration mode using the config command. Then interface fast Ethernet 0/0 IP address. The IP address for the interface fast Ethernet 0/0 is 192.168.12.1. The mask is /30, which means 255.255.255.252. Okay, then no shit to enable the interface. By default, the interface is disabled. Okay, and exit. Very simple. Now we will configure the loopback IP. The interface loopback 1 and the IP associated with that interface is 1.1.1.1 and /32, which means 4 times 255. Okay, exit. Save the configuration. You can save it using the write command. Now let's verify the interface IP addresses and the status. You can execute show IP interface brief. Okay, you can see that the interface fast Ethernet 0/0 is having IP 192.168.12.1. The status and protocol both are up. And you can also see for the loopback IP, which is 1.1.1.1. Status protocol both is up. Okay. Now let's begin with the R2 router interface IP address configuration. Okay. Okay, so you can enter the global config mode using the config command. First, we will configure the interface fast Ethernet 0/0, which is connecting to R1 router. The IP address for this interface is 192.168.12.2. The mask is /30. Okay, no shutdown. To enable the interface, by default the interface is disabled. Exit. Now we will configure the second interface, which is fast Ethernet 0/1. This interface is connecting to router R3. Okay, IP address. The IP address for this interface is 192.168.23.1 followed by the mask. No shutdown. To enable the interface, exit. And we will also configure the loopback IP. The loopback for R2 router is 2 and the IP address is 2.2.2.2 and the mask is /32. Okay, exit and save the configuration. Let's verify if we have properly configured the interface IP. You can execute the command show IP interface brief. Okay, now you can see that for R2 you have fast Ethernet 0/0 configured with IP 192.168.12.2. Interface fast Ethernet 0/1 is 192.168.23.1 and loopback 2 is 2.2.2.2. For all these three interfaces, the status as well as the protocol is up. Okay, I will save it once again. Now let's begin with the router R3 interface configuration. Okay, let's enter the global configuration mode using config command. Enter the interface fast Ethernet 0/0. The IP address is 192.168.23.2. The mask is /30, which means 255.255.255.252. No shift. To enable the interface, exit. Now enter the interface loopback 3 because we need to configure the loopback IP. The IP address for this is 3.3.3.3 mask 255.255.255 and 255. Okay, and save the configuration using write command. And let's verify the interface IP status. Show IP interface brief. Okay, you can see that we have fast Ethernet 0/0 configured with 192.168.23.2 and we have the loopback IP. The status as well as the protocol both are up. Okay, now let's check the routing tables of each router. We are on the R1. To check the routing table, we can use the command show IP route. It will list the routing table the router R1 knows. So you can see that this router R1, it knows only the directly connected networks. For example, this C code means directly connected. So on interface fast Ethernet 0/0, this router knows 192.168.12.0 is the network which is connected. And on loopback 1, this router is connecting with 1.1.1.1 IP. Okay, so let's verify the same for R2. You can execute the command show IP route to check the routing table of R2. Here R2 knows few network. For example, on fast Ethernet 0/0, R2 knows that we have 192.168.12.0 configured. Okay, as shown in the topology diagram. Okay, and on the other interface fast Ethernet 0/1, R2 knows 192.168.23.0 is directly connected. We also have a loopback 2 IP. So this is the routing table. And let's see for R3. Show IP route. So R3 also knows about two networks. One is the directly connected on fast Ethernet 0/0. The network is 192.168.23.0, and there is one loopback also, loopback 3, which is 3.3.3.3. But as per this routing table, we can observe one thing, that the R1 router doesn't know the network between R2 and R3. Okay, if you look at carefully this routing table on the R1, you will see that R1 doesn't know the network for this 192.168.23.0/30. Okay, so let's try to check the reachability. Okay, first I will check if R1 can ping to R2. Okay, the R2 IP is directly connected network 192.168.12.2. This is the R2 IP. Okay, yes, so I am able to ping the R2. Now let's try to ping R3. So R3 is 192.168.23.2. Okay, let's see. Okay, so I think I am not able to ping the R3 router because this network 192.168.23.2 is not in my routing table, in the R1's routing table. Okay, so similar case, we can check from R3 if R3 can ping to R2. Let's see if the directly connected network which is on the towards the R2 can be reachable. Yes, I can ping 192.168.23.1. So 23.1 is which IP? Okay, this IP belongs to R2 interface. Okay, so R3 is able to ping R1, sorry, not R1 but R2. Let's see if R3 can ping R1. So I will try to ping 192.168.12.1 IP. Okay, so I am not able to ping the R1 router. So first thing is that we don't have the complete network reachability between R1, R2 and R3. Okay, so you can use any of the routing protocols, interior routing protocols such as RIP, eIGRP, OSPF, or you can also use the static routes. So I will make sure that I have the reachability between R1 and R3, and for this I will use a very simple routing protocol, that is a static route. Okay, I can use the static route. If you want, you can use the OSPF, you can use the eIGRP, or even RIP routing protocol. But for simplicity, I will use the static route. So I want to reach 192.168.23.0. The mask is, and the next stop. Okay, this is the remote network I want to reach, the remote network mask, but the next stop. Okay, if you put a question mark, it will ask for the next stop. So forwarding router address like this. This is the next stop. So if I want to reach to R3, I have to forward the packet to R2. Okay, for example, R1 wants to reach the network between R2 and R3. So R1 will forward that packet to R2. So R2 IP is 192.168.12.2. So that is my gateway IP, 192.168.12.2. Okay, let's see if our routing table is populated with this new information or not. Okay, yes, you can see that 192.168.23.0 is via 192.168.12.2. So let's see if I can ping the R3 router or not. Okay, I still can't ping the R3 router. The reason is very simple, because we don't have the return route. Okay, R1 knows how to send or how to reach this network via this next stop, but the return route from R3 doesn't know where is R1. Okay, if you see at the routing table, it is not having the entry for 192.168.12.0. Okay, so R3 doesn't know the return route. So I have to configure a static route also on the R3 for the return route, which is 192.168.12.0. The mask is /30, and for R3, R2 is the next stop, so that should be 23.1. If you look at the topology carefully, you will see that 23.1 is configured on the R2. So this is the return route for R3. Okay. let me save the configuration. Let's check the routing table once again. Okay, you can see that we have a static route 192.168.10.12.0 via this next hop. So let's see the connectivity. Previously, I was not able to reach the R3. Okay, but now I can reach the R3 router. I will also cross verify the reverse connectivity from R3 to R1. The R1 IP is 192.168.12.1. Okay, fine. So till now we have the clear reachability between R1, R2 and R3. Okay, now we will start with the BGP configuration part. Okay, let's start with the BGP configuration on the R1 router first. Okay, it's very simple configuration steps. You can enter the global configuration mode using the config command. Enter the command router BGP. It will ask for the local AS number. So as you know that we are using the AS number 65,000 for all the routers. Okay, then you can execute the command neighbor. So for R1 the neighbor is 192.168.12.2 means R2. Okay, 192.168.12.2 and the remote AS is 65,000 because we are forming iBGP. If you see R1's local AS number and the remote AS number for R2 both are same, so we are forming a iBGP. Okay, we can advertise the network 1.1.1.1 because we want to only advertise the loopbacks. Okay, we don't want to advertise any other subnets. We only want to have the loopbacks advertised over the BGP to check the connectivity, and we will also enter the mask. Okay, I will save the configuration. Okay, if you want to see the BGP configuration, you can use command show run pipe section BGP. Okay, this is your BGP configuration command. Very simple. Now let's configure R2 for the BGP. Now you can see that R2 is connected to R1 as well as R3. So on R2 you can see that we need to form two BGP sessions. One is with the R1 to R2 and second is R2 and R3, and we will advertise the loopback IP 2.2.2.2 in the BGP. So let's begin. Enter the global configuration mode. Now router BGP, we have 65,000 as the local AS number. First we will form the neighbor with R1, then R1 IP is 192.168.12.1. Okay, and the remote AS is also 65,000. Now the second neighbor is 192.168.23.2, which is R3. The remote AS number is 65,000. Okay, and we will advertise the network, the loopback IP, which is the command mask. Okay, meanwhile you can see that there is one pop-up. Okay, the BGP neighbor was formed with the R1 router. The BGP is up with the R1 router, but not yet with the R3 router. Okay, so we are done with the configuration on the BGP for R2. Let's verify the same. Show run pipe section BGP. Okay, you can see the configuration. This neighbor belongs to the R1 router and this neighbor belongs to the R3 router, and we have advertised the loopback IP 2.2.2.2 using the mask command. Okay, fine. Now let's begin the BGP configuration on R3. Enter the global config mode. Router BGP 65,000. Enter the neighbor command. Now for R3, there is only one neighbor, which is R2. Okay, so the R2 IP is 192.168.23.1. Remote AS is also 65,000. We will advertise the loopback IP in the BGP. The mask is /32. Okay, end command and save the configuration. If our configuration is correct, then you should see some BGP pop-up. Yes, we got the BGP pop-up. That BGP is up now. Okay, now let's verify the BGP session between R1 and R2 router. I will go to the R1 router. The command is very simple, show IP BGP summary. Okay. So here you will see that the local router ID is 1.1.1.1. The local AS number is 65,000. The remote IP with which we are forming the BGP is 192.168.12.2, which is the R2 router. Message received, message sent 6. This is the AS number for remote router. And you can see that the BGP is up since more than 2 minutes and one prefix has been received. If you want to see the prefix, what is that prefix? You can enter the command show IP BGP. It will show you the BGP table. Okay. So from this neighbor 192.168.12.2, you can see this neighbor here, next hop IP. Okay. This prefix has been received 2.2.2.2/32, which is valid and which is the best path. Okay. So this, if this is entered in the BGP table, it should also be installed in the routing table. So we will check the routing table of R1 router. Okay. In the routing table, you can see this B code. So B code means BGP. Okay. B code means BGP. And via BGP, we have learned this 2.2.2.2 via 192.168.12.2. Okay. Let's verify the BGP on outer router. I will go to the outer router. Same command, show IP BGP summary. Okay. Here you will see that the local router ID is 2.2.2.2. The local AS number is also 65,000. On R2, we have 2 BGP neighbors. You see this? Okay. So this neighbor belongs to the R1. BGP version is 4, 65,000 is the AS number, message sent, message received, and this session is up since more than 3 minutes. You have received one prefix from the R1. The second one is the neighbor for R3 with version 4. 65,000 is the remote AS number, message sent, message received, and this is the uptime for BGP, 2 minutes and 12 seconds. One prefix has been received. If you want to see what prefix has been received, enter the command show IP BGP. It will list out the BGP table. Okay. Now, if you look at this neighbor 12.1, you see this 12.1 next up. So from R1, you have received 1.1.1.1, which is best and valid route. And from this neighbor 192.168.23.2, which is R3, you have received 3.3.3.3/32, which is also a valid and best path. Okay. If I check my routing table, show IP route, you should see 2 routes from the BGP. Okay, as expected. You see this B code. Okay, so this B code means BGP, and from R1 you have received 1.1.1.1, and from R3 this B code you have received 3.3.3.3. Okay, now let's verify R3 router for the BGP. So you can execute the command show IP BGP summary. R3 should have only one neighborship. Yes, we have. This is the router ID for R3. We have the local AS number 65,000. R3 is forming neighborship with R2. The BGP version is 4. 65,000 is the remote AS number. Message received, message sent is 9. This is the BGP uptime and one prefix has been received. Now what is that prefix? So show IP BGP. It will list out the BGP table. Okay. So you see that, very important. R3 only knows about the 2.2.2.2, which is the valid and best path from this. But the question is, where is 1.1.1.1? Okay, do you see this 1.1.1.1 okay being learned from R3? Okay, this 1.1.1.1 is sent via BGP to R2. Okay, because we have checked the R2 BGP table. See this in R2 routing table also. In R2 routing table, you can see that 1.1.1.1 is available, but R2 is not sending that information to R3. Hence, you will not see 1.1.1.1 in the BGP table or in the routing table of R3 router. See this? You will not see. So why is it so? Very simple. This is the BGP Split Horizon Rule, which clearly mentions that a route learned from one iBGP pair will never be transferred or will never be advertised or forwarded to another iBGP pair. Means 1.1.1 was learned by this R2 router via the BGP, but R2 did not forward it to R3 because of the BGP Split Horizon Rule. Okay, if you want to check the connectivity, we can also check that. Can I ping 2.2.2.2 using the source 1.1.1.1? Yes, I can ping. Okay, can I ping 3.3.3.3? No, I cannot, because you will see that even R1 did not learn any information about the 3.3.3.3 loopback. If you see the routing table carefully, okay, there is no 3.3.3.3. Means what? R1 doesn't know anything about loopback 3.3.3.3 and R3 doesn't know any information about loopback 1.1.1.1. Okay, only R2 knows about that. So routes learned from R1 to R2 will not be forwarded to R3, and routes learned from R3 by R2 will not be forwarded by R1. So this is the BGP split horizon rule. So how to solve this problem? This problem can be solved by BGP route reflector or BGP confederation. So we will cover those topics later in coming videos. I hope this video was informative and we will see you in the next lecture. Thank you.